Here's an interesting question. A convenient substitution for the number of seconds in a year is pi times 10 to the 7th. To within what percentage error is this correct? All right, well, first of all, let's figure out how many seconds there are in a year. So 1 year, and we're going to multiply this by a series of unit conversions to break it down into a number of seconds. So on average so we'll start with days in a year. So on average there are 365.25 days in a year. Now moving from days to hours, there are 24 hours in a day. Moving from hours to minutes, there are 60 minutes in an hour. And similarly, when we move from minutes to seconds, there are 60 seconds in a minute. So first of all, let's check to see that our units all cancel out appropriately. The years cancel with years, the days cancel with days, the hours cancel with hours, and the minutes cancel with minutes. And we're left with seconds. So if we multiply all this together, 1 times 365.25 times 24 times 60 times 60, and what we get is 1 year is equal to 31,557,600 seconds. Another way to write this is 3.15576 times 10 to the 1, 2, 3, 4, 5, 6, 7 times 10 to the 7 seconds. Not surprising. Pi times 10 to the 7th is going to look something like this. Pi times 10 to the 7th. If let's say we carry pi out to this many figures as well, this is about equal to 3.14159 times 10 to the 7th. So let's see, and this is the estimate for the number of seconds in a year. So let's see what this percent difference is. And if the numbers are already pretty close, we can see that. Well, how close? Well, the percent difference is going to be, specifically the percent difference of the estimate from the actual number is going to be equal to the estimate minus the actual divided by the actual. Now in this case, that's going to be equal to 3.14159 times 10 to the 7th minus 3.15576 times 10 to the 7th divided by 3.15576 times 10 to the 7th. The good news is the 10 to the 7ths all cancel out, so you don't even really need to worry about that. So we can just say 3.14159 minus 3.15576 divided by 3.15576. And I get, this is about equal to minus 0.00449, or minus 0.449%. And this will all depend on whether or not you used 365 days for a year or 365.25 days in a year. You'll get a different number depending on what you use there, and how many, and also how many figures you take your calculations out to be in the interim here. But those things, they matter, but not. The point is, to know how to do this problem and how to answer the question they're asking. And in this case, the estimate is less than 0.5% shy of the actual number of seconds in a year, which is pretty darn good.